Introducing Ada AI Drilling Series, part of the Ada AI digital ecosystem. Drilling Series unlocks operational cost optimization, risk reduction, and well site decarbonization through data-driven automation. Solutions tailored to predict ahead in real time and continually improve performance based on your historical data, ensuring consistent operational success of your wells. Consistently predict your path to cost optimization. Effectively predict your path to decarbonization. Confidently predict your path to success. Ada AI Drilling Series. Predict your path to overcome your challenges.
I am Beth Fawcett, Research Data Scientist at Enovate Upstream. And welcome to yet another virtual Ada AI digital ecosystem launch. Thank you for attending, and if you missed the live event at ERTEC 2021 with Diego Junca, Drilling Series Product Owner and Senior Drilling Engineer, I am happy to have you join us today virtually. The Ada AI digital ecosystem is comprised so far by the Drilling, Completions, and Production series. Today, we will be taking a deep dive into the Drilling series modules. Now, it is my pleasure to finally introduce you to the solution to truly integrate geomechanical properties and both historical and real-time data. In order to address and overcome the most prevalent challenges our industry faces today as they arise, the Ada AI digital ecosystem is a predictive technology that puts your data to work when using a fully integrated cloud-based solution that starts with our Drilling series modules, which include first, drilling optimization, second, business intelligence, or BI, and third, logging production. Guiding us through what each module has to offer is our global AI deployment lead, John Estrada.
At Enovate Upstream, we perform a comprehensive research on different areas of the oil and gas industry, including key points as actual market needs, process optimization opportunities, and customer feedback. Ada AI ecosystem is our flagship for the current digital transformation, which is built based on the next 6 core principles. First, data utilization optimization, which converts data into real tools for the optimization of the operations, reducing lifting cost and carbon footprint to make a more sustainable portfolio. Second, connectivity and integration. This incorporates all the variable analysis and the possible solutions in a single tool, accessible anywhere, anytime. Third, flawless and efficient processing. How to create a reliable and replicable process that integrates historical and real-time well data in a powerful tool. Fourth, predictability and automation. So, how to optimize the well delivery process by predicting behaviors, tendencies, and performances. This helps anticipate risks and optimize our response to undesired events. Fifth, empowering resources. Good performance, risk mitigation, and fast problem-solving recommendations by taking good decisions. And finally, continuous improvement. How to connect every single module in a single environment. Welcome to Drilling Optimization, a module of the Ada AI Drilling Series offering. Our goal is to empower users via a user-friendly and intuitive interface that improves drilling performance, particularly the ROP. The module provides monitoring, control, and real-time optimization of drilling operations. This module is cloud-based, therefore, you can access this dashboard anytime, anywhere, via an internet web browser or by using an intrinsically protected mobile tablet. Ada AI Drilling Optimization incorporates multi-dimensional analysis of the drilling assembly, well trajectory, rig type, MSE and formation characteristics to provide a range of suggested drilling parameters that historically have yielded top-tier performance. Continuous and steady improvement when consistently used from well to well. The dashboard provides performance metric through the MSE versus ROP relationship. Let's get started.
A username and password are assigned to each user to access the dashboard. Ada AI Drilling Optimization incorporates multi-dimensional analysis of the drilling assembly, well trajectory, rig type, MSE and formation characteristics to provide a range of suggested drilling parameters that historically have yielded top-tier performance. Here on the main dashboard, from top to bottom, an internally automated code provides the operations being carried out real-time. Here, the hole and bit depths are listed to provide a reference to the user. Then, the drilling parameters that can be adjusted to yield a top-tier performance are listed at the top. A color code informs the user that the given parameters is out of the suggested range. Red, like here, for out of the range, and purple when the parameters are within the range. The suggested drilling parameter ranges are presented in a way of envelope. This purple roadmap here. These recommended parameters, they change with depth. We call these envelopes roadmaps. They provide a guide to the driller to adjust the drilling parameters to achieve an optimal ROP based on historical performance from wells used during the training of the machine learning model. Similarly, the tracks turn red, like here, whenever they're outside the range. This quickly informs the user about this suboptimal condition. Here, the name of the formation and lithology is listed as a reference that can be adjusted real-time. The ROP track informs what is the optimal ROP expected for that given depth, formation, TFA, and trajectory. This is this vertical line informing the threshold. Here on this right-hand side of the screen, there is the MSE versus ROP plot that informs in a quick view how optimal the drilling activity is being carried out. There are 4 quadrants. The best condition in terms of drilling efficiency occurs here, where you have high ROP and low MSE, here in purple. And the worst conditions in terms of drilling efficiency, where you have a very high MSE and a very low ROP, here in light red. The other 2 quadrants are intermediate conditions. In this example, most of the points, the historical points, are in red here on these 2 quadrants, quadrant 4 and 3rd. That tells the user that there's a lot of room for improvement. In this case, if the driller followed the suggested parameters, the ROP could be increased. Finally, the Enovate Upstream circle changes in color depending on the level of drilling efficiency. Red, like here, for very poor efficiency, and purple when the efficiency is high. The user can scroll up and down to see the performance during the previous depths. And you can go back to the current depth. On the settings screen here, selecting this bottom. From top to bottom, you can select the unit system and type in the name of the well and the project. The scales can be changed according to the behavior of the data. In the lithology window, clicking here on this lithology letters, the end user or the 24/7 technical support can upload the envelopes or roadmaps as a CSV file. Clicking here on the import envelope and selecting the CSV file. Here the different formations can be selected from the drop-down option. Formations can be added here on Add Schedule, and just selecting the formation name, the bit size, the type of formation, the depth, the bottom of the formation, the revolutions per gallon of the mud motor, and the TFA. You can also delete formations. Originally, this information would start with the geological prognosis before starting the drilling of the well, and then this information can be updated anytime as the operation progresses. When you're ready, click Save. This window will tell you that the information has been updated successfully, and then you can click Run to go back to the main dashboard.
By simply following the dashboard recommendations, users can drill with reduced risks, knowing they will achieve optimal performance while also conforming to the safety limits of both the rig and formations being drilled. Welcome to Business Intelligence, a module of the ADA AI Drilling Series offering. Our goal is to empower users via user-friendly and intuitive interface that improves drilling performance through a detailed tracking of the activities involved during the well construction, such as tripping and drilling. The platform allows users to compare the metrics of a current well versus a set of historical wells in an interactive dashboard. It also allows for the export of detailed performance reports. The platform provides a filtering feature to select only those wells that have a comparable feature similar to the current well. BI imports real-time data collected from the rig site and also historical information to retrieve optimization opportunities and potential cost savings. You can compare in a simple view the performance of the current well versus historic wells selected by the user. It is very easy to implement due to its cloud-based environment. All you need is access to an internet browser. Let's get started. All you need is a username and a password. The first view of the dashboard is the settings screen. To the left, you can create new scenarios or projects, or retrieve an existing one. For this demo, I have already created one scenario for you. I have imported all the drilling information from the offset wells here, which includes the drilling parameters observed during the construction of these historic wells. If you have a directional plan and time versus depth plan and the geological prognosis, you can upload it here. If the information of the historic wells are on the database, you can establish a connection clicking here, Connect to Database. All the information is loaded now, and you can perform a first filter by location, field, or rig. The main objective is for the user to compare similar wells. The well design describes the architecture of the well with the number of sections, the hole diameter, and casing diameter per section. The next filter is the well profile, J, S, horizontal or vertical. Once you click Run, the dashboard looks for all the wells that fit the criteria selected before. The machine learning algorithm also produces the worst and best performance possible from those wells to define the operating boundaries. The dashboard has found these wells that fit the criteria. In order to allow an apple-to-apple comparison, the dashboard provides a second layer of filtering. The first one is the well construction rate, WCR here. The idea is to compare wells with a similar performance. Here you can avoid from the study those wells with poor performance. The second point of comparison is the well difficulty. We want to compare wells that have a similar trajectory and similar directional difficulty. A standard metric for this is the DDI, the directional drilling difficulty. The ranges are listed here. We have two views that are commonly used in the industry, the depth view and the reach view, also known as the dog nose plot. We can also click on Fit the Data to fit all the wells in the same view. Similarly here, you can scoop out those wells with outlier well difficulties. Once the wells are filtered and selected, the metrics, statistics, and KPIs are produced. At the top, we have the time versus depth plot. This represents the time elapsed on the well construction. The machine learning algorithm has produced the best and worst envelopes, red for worst and purple for best. The plan here is represented by the green dashed line. Just by seeing at this plot, the user can observe that the plan is leaning more towards the worst performance. The user can change, therefore, the plan accordingly if necessary. On the activity distribution, we have two plots. Here is a summary of the activity distribution per well. This can be represented by percentage or by hours spent on each of the activities listed here. The user can retrieve the information per each particular section and also a specific activity, such as drilling or tripping. To the right, the user can see the technical limits based on what was observed on the wells selected. The box plot represents the best, average, and worst performance. Once the real-time connection is established, the current well information is shown on the time versus depth plot, and also here on the KPIs. The user can see in a single view how the current well compares versus the historic wells. If we click here, we can access to the drilling tab. Here we have 6 different plots. Because of the amount of information available, it might seem a little bit overwhelming. Because of this, we can select only the range of data we want to see. We can do it by time or by depth. Let's do it by depth and select the range of data we want to visualize. At the top, you can see the current measured depth, bid depth, and current rig activity, calculated automatically from the code. Now, let's take a look at the 3 plots at the top. The performance plot, drilling parameters, and directional. The performance plot provides the performance versus depth. You can see the formations, also the envelopes of the technical limits of the ROP, also the ROP efficiency, as a relationship between the MSE and ROP. And finally, the wait to wait and sleep to sleep time. The parameters and directional are located side to side to the performance plot to easily identify the relationship between them and the drilling performance. The directional plot compares the plan versus the current well and also provides the statistics of the slides versus rotating per stand. Ada AI logging prediction tool predicts real-time logging curves by incorporating AI models. This module allows the prediction of real-time quad combo curves by utilizing operational, geological, and offset logs to create a specific AI model capable of being run in your chosen well. By implementing this adaptive technology, the learning capacity of the model and accuracy of the predictions is dramatically improved with the incorporation of additional data. Because of this, it is scalable to any environment with minimum adjustment and retraining of the model. This technology can be implemented in any project, reducing the requirements for logistics associated with conventional logging techniques, reducing the risk associated with radioactive sources and lithium batteries at the rig site, optimize drilling operations using logging prediction as a backup application for challenging data acquisition programs, filling up data gaps when for some reason the logs couldn't be obtained.
Thank you, John, for your time and expertise, and to everyone who has joined us today. Before we close out, I would like to highlight a few key points from each of our drilling series modules. In drilling optimization, you will consistently improve ROP. In BI, you can maximize the drilling performance analysis through real-time monitoring of the critical parameters and KPIs. In logging prediction, you can predict real-time quad combo curves by incorporating AI models by leveraging operational, geological, and offset logs. Remember that our drilling series software tools will help you get more out of your drilling operations by leveraging digitalization, cloud computing, and integrated production modeling. The Ada AI digital ecosystem is a predictive technology that puts your data to work.
Hello, everyone, and thank you for watching our product launch video. We'll be transitioning into the Q&A. And the first question that I have is actually going to go to our CEO, Camilo. Where have you been running the technology so far, and do you have any case studies to share?
Thank you, Beth, for the question, and thank you to the audience for joining the launching event today. Yes, we have been kind of building the technology with customers in the US. We were collecting data from, well-known bases like Eagle Ford, the Permian. Then we translated the operations to Latin America, collecting data in countries like Colombia, Argentina. We have several papers that we invite everybody to kind of read as papers. We can follow up with anyone who wants to learn about the case studies for sure. So it's been a journey for the Enovate team. The drilling team has been working with customers, collecting data, improving the algorithms. The prediction technique here was the main target, how we can achieve accuracy of the models as well as the repeatability of the codes. And the journey has been very successful so far. Thank you, Beth.
Thank you, Camilo. Our next question is going to Diego, who is the product owner for the drilling series products that you've seen today and our senior drilling operations person. And the question is, while I understand that a specific AI model needs to be created and trained to generate a logging curve prediction, can we increase the accuracy of an existing AI model? And how can we increase that accuracy of any model?
Hello, everybody. Thank you for being here in this launching. And answering the question, yes, we may improve the accuracy of any AI model at any moment if more relevant data is available. Our models utilize basic operational and geological information, but the improvement of the accuracy can happen increasing the number and the detail of the input features. For example, we can add mineralogy, and the accuracy will improve automatically. And also, we have another well-known models or techniques to improve that accuracy as the cascade model, where a predict curve is used as an input feature to generate another curve. So this is the kind of process that we optimize the data and how we utilize that optimized data.
Thank you, Diego. My next question is for Evgenia, who is our Chief Research Data Scientist. Many researchers report large variability in drilling data from well to well. How do you address the variability and how does it affect model performance?
Thank you, Beth. Hi, all. I'm happy to be here and address the question. Well, first of all, we built the drilling preprocessing pipeline in order to collect all necessary information that comes from different pieces, so that we can properly partition and separate data before we feed them into the machine learning model that predicts ROP. Basically, we'll put together only comparable wells with criteria defined by domain experts. For example, well trajectories, the same beat type, the same beat size, and formation. And at the end of the day, our model built on the data, and we depend on data from best performing well. In this way, we can ensure that our product provides best models, and in case schedules are followed, it's designed to develop continuous improvement for your ROP performance. Thank you.
Thank you, Evgenia. And our next question is actually going back to Diego. As part of the Ada AI digital ecosystem, can these platforms interact with other platforms within the drilling series or the production series offerings to create a closed loop of information flow and optimization?
Thank you, Beth, for the question. And the answer is yes. All our tools have that specific approach. Optimize the data utilization and standardize and connect the process on different disciplines. For example, the output data of the drilling optimization tool, for example, MSE and ROP, is used as data input feature for our completions design tool, which is Sustain Design. And the output data is useful, that output data from that tool is useful for to date the production forecasting tool. So this process will improve basically how the decisions are made and assure that we include all the lessons learned and the real-time information during the execution phase. So everything is connected, can be interacted, and we will bring the data to every specific series. Thank you.
Thank you, Diego. And my next question goes back to Camilo. Is decarbonization for me, decarbonization is easier to achieve in production, but for drilling, how does your technology help with decarbonization and achieving net zero goals?
Thank you, Beth. I think that's a great question. There are several layers when it comes down to decarbonization, especially from the drilling side. The first layer is about the optimization of operations, having a tool that can precisely evaluate the operational time, which is directly translated to the footprint. By doing so, there are so many ways how we can have more clear estimates, calculations, or prediction of CO2 emissions. That's actually the first benefit of the technology. The second benefit of the technology, as we grow in the industry and as technologies evolve, the governance is also one of the challenges when it comes down to achieve net zero goals. Having the capacity to validate, certify how much CO2 we are emitting during the drilling operations is going to be key for success. So to summarize, there are two different values when it comes down to the net zero goals, or specifically decarbonization at the field side, at the field level. The first one is actually the opportunity to have a tool that can quantify the operational footprint that is directly translated to CO2 emissions. And the second one is the opportunity to have a governance tool over time for whatever the purposes are. Thank you, Beth.
Thank you, Camilo. Our next question is going to Diego. How can the dashboard assure that the filtering options are working properly to identify and compare accurate KPIs of the historical performance?
Thank you, Beth. And that is a great question. And it was included during the design of the tool. And because that is basically the main, one of the main features, be able to compare in a good way. So on the overview tab, the filtering option has three methods that allow the final user to validate the selected wells are comparable between each other and between the offset data and the well that you are going to execute. The first method is related to the performance, which is well construction rate. This is a measurement of how many days took to build the well or a specific section. It includes the drilling and the tripping and all the phase, build the entire phase. The second method that we implement here in the code to, confirm that we are comparing apples with apples is related with the directional performance, which is the DDI. And this method is used to determine how difficult it is to drill a directional well and include measurements, key measurements, basically, as the measure depth, tortuosity, true vertical depth, etc. And as you know, there are specific standard. This is specific standard industry that will help to determine that difficulty in several range, right? And the third one is a method related with the type of well, which include the unwrap departure and the reach of the wells. So this method can provide the final user of an idea of the well and the torque and drag behavior that he can expect on the new well and the performance that they have in the past. As a summary of the, all these methods are a tool that will assure that you are comparing the properly the wells that you are planning to execute versus the offset data. Thank you, Beth.
Thanks, Diego. Our next question is for Evgenia. Do you retrain machine learning models in real time? If so, what happens if the previous prediction changes and how do you track it?
Thank you, Beth, for the question. Yes, we have this feature for login curves prediction tool. And in case, LW data available in real time, we do retrain them, but we do it every certain footage drilled, for example, at every 1,000 feet. And then the dashboard will show you by default the latest model, most updated and with the best scores. However, all the previous models that have been used and shown also can be accessed on a different screen. If I remember, it's to the left, where you can access it they are labeled by depths. So you have access to the current best performing model together with past predictions. Yep, thank you.
And our next question is also for you, Evgenia. What techniques do you use to obtain rig activity labels?
All right, thank you again, Beth. Rig classification algorithm lies in the heart of all business intelligence drilling products. And in order to obtain these labels, our developers together work together with domain experts to build AI algorithm that provides you labels, which is based on rig parameters, list of thresholds applied to each rig. And, the algorithm performance is tested for each rig. And these tables are built and checked by domain experts. And it's all done in an efficient manner because they build it once for a rig and then it's reused during further operations. Thank you.
Thanks, Evgenia. And for this next question, I'd actually like to get your opinion, Evgenia, and yours as well, Diego. The question is the Ada AI dashboard a pure machine learning tool, or is it coupled to some models that depend on physics, as in data physics?
Regarding the drilling dashboards, the part that I just talked about, this rig labeling, because there's a lot of input from domain experts. I believe that the physical component is there because we depend on actual rig parameters that will identify your labels, for example. But I know that in production model, there's a lot of physics-based model involved. Drilling has a mix data-based and physics-based inputs. Thank you.
Diego, if you could give your perspective working as a drilling engineer with some of our data scientists.
Basically, Gina says a good point. But yes, I think that from the drilling series, the component, the physical and the data scientist component are really interconnected, and we try to put all the knowledge and experience in this specific dashboards in order to provide a powerful tool and be able to build something powerful as an ecosystem that can be connected and deliver the results, not only for the drilling. As I mentioned before, it's about to connect everything, all the disciplines, and transform the process and improve the process.
Thank you both for your answer. Our next question is actually going to Camilo. What is your customer target market? IOCs, service companies, etc.?
Thank you, Beth, for the question. I think the customer profile is less relevant than actually was the strategy the customer is using. We see several, strategies around digitalization and operational optimization. So regardless, we have the ability to be flexible, whether the customer is looking for a kind of full developed technology that can be plug and play and optimize operations, or is a kind of integration strategy, meaning we just share our kind of, backend and plug into what customers are using. So more than the customer profile is actually the digitalization strategy for operational optimization. We are actually in the path of flexibility, trying to support the customers with any strategy they have.
Thank you, Camilo. And our next question is going to Diego. How long does it take for someone to learn the drilling software that's been presented today?
Thank you so much for the question. Basically, it's as we mentioned at the beginning, it's very intuitive. However, part of our deployment plan for every customer, every final user, is to give the proper training on the field with the tools and the devices that are needed for the deployment, and it won't take more than 2 days on the rig, because we need to show on the field that this is a support tool. This is not something that it will replace them. It's a support tool, so it's very easy, it's very intuitive, so it won't take more than 1 to 2 days to train, for example, a rig crew. And going to the office, we are going to be with you guys doing the support that you request 24/7, but 1 day just to get the access, to be familiar with the formats that we can collect and that we can use to collect the data. It won't take more than 1 day. So it's very easy, it's very fast, and we can handle from you. Additionally, this is a process that we build with you guys. It means that we exchange the data, we build the models, we show the results with you. So at the first moment, you start to be part of our product, and we start to be part of your company, sharing the knowledge and sharing the experience. That's why it's really important, the technical approach that Enovate provides to you. Why? Because it's not only to talk in different language. It's the operational point of view, the engineering point of view, trying to match that with the data scientist point of view. So that is really quick training, and we start in the first moment of that we start the exchanging data.
Thank you, Diego. So our last couple of questions all deal with data and how it's managed. there was a question about, are we gathering real-time data, and is the driller actually getting notifications based off of this real-time data, or is it just for the back office? Some of the input data is, does it include bit design? And are we dealing with a kind of like a triple combo data based on geology, drilling, and other parameters? How do we validate that data? And then what's the minimum amount of historical data that's needed? So there's just a lot of questions about real-time data. So I think, Evgenia, if you could speak to how Enovate manages real-time data and historical data and validating what's going on.
All right. I think Diego started talking about this process, how we start getting the data. Like before, before the dashboard is working, we need to obtain the historical information. For example, for business intelligence dashboard, we need at least, I would say, 3 wells in historic information upon which we can build some KPIs, envelopes, for best and worst performance. But yeah, we have our own process collecting the data. We need all the drilling information. Well, it depends on the product. And then we also need to know information about bit sizes, BHAs. We want to put as many pieces of information together to be as accurate as we can. So yes, we work, we have this whole workflow, how we collect the data, and it takes some time in the beginning. So we ensure we have everything we need to produce, for example, a business intelligence dashboard with all the KPIs. And then real-time data. Yes, we need to set up real-time streaming for our dashboards to function and to show you information in real time. And we also process this real-time information and do calculations relevant for each dashboard. But yeah, we have all these processes in place. And in the beginning, it will take some time for us to get the new data. For example, every client we work with has slightly different data formats, so we need to adjust for that. But we already have quite a lot of experience taking different formats, and our process overall got faster as far as I can tell.
And if you could speak to how we validate what's happened in the process so far.
Yeah, sure. It depends on the product. Let me talk about business intelligence. It's done, as soon as we build models, for example, predict rig labels, our domain expert will go and check that, because it requires domain expertise to make sure that all the labels have been done correctly. So we have this phase of testing it. For example, for ROP optimization, we have the data, we have, classic machine learning metrics, like we can check the accuracy, F1 score, how our model performs, given that we train on, the wells provided and test on the other well that we haven't seen. We do this kind of validation. Depends on the product. It's the same for logging curves. We need at least 2 wells to train on one and test on the other, the predictions, and make sure that the scores are good. Like never one score is good. We can rely only on R square. We look at the R square and absolute percentage error. We have different metrics to test, but we use classic ones for machine learning related problems. Does it answer the question, Beth?
Yes, thank you so much.
Okay.
All right. So that concludes the question and answer section. Thank you for attending today and for all of your questions and interest in our drilling series modules, drilling optimization, business intelligence, and logging prediction. This meeting has been recorded and will be posted to our social media channels. And if you would like to follow up with us, please feel free to contact us at enovate.ai/contact. Thank you.